Alright, this video I'm going to look over solving equations with rational exponents. Rational exponents, that's just having an exponent, but with a rational number there. A rational number being that fraction. So we would like to solve this. The only issue here is I got x on both sides. So with all solving videos I talk about if you want to solve for any variable like x, y, or whatever, you always want to work the order of operations backwards. The only issue here is we have to take our x's and get them together. The issue of why I can't just subtract this x to the other side is this exponent here of 1/2. So I'd like to get rid of that 1/2 exponent. Well, recall there's a few things going on here. When you have a 1/2 exponent, so anything to the 1/2 exponent, that is the exact same thing as taking the square root. So if it was a 1/3 exponent, it would be the third root, vice versa. So kind of like how if we want to get rid of a square root before, we squared everything. If you want to get rid of a cubed root, you cube everything. That's going to apply here. The other mathematics behind it is we're going to be using properties of exponents. So what we're going to have is we're going to have a 1/2 in our exponent, and since we're following ideas of radicals as well here, we're going to square it. So up in the exponent, we're going to have 1/2 times 2. Well, recall 1/2 times 2 is just 1. So that's going to simplify the 1, which just leaves this parentheses. Anything to the 1 power is whatever you have. So those ideas there are in play here. So what's going to happen is we have x plus 12 to the 1/2 power is equal to x. To get rid of the 1/2, I'm going to square the entire left side and square the entire right side. The reason again I'm doing that is 1/2 times 2 is 1. So we're going to have x plus 12 to the first power. On the right side I have x squared. And like I was saying, anything to the first power, well, that's irrelevant to us. So we have x plus 12. Anything to the first power is just whatever we had. So x plus 12 to the first power is x plus 12. So I have x plus 12 is equal to x squared. So very similar to my solving radical equations, my second video, this is a quadratic problem. The reason I know this is I have an x squared. There's many ways of solving this: square roots, solving by factoring, completing the square quadratic formula. One thing that we always like to do is we'd like to get this equal to 0. So what I'm going to do is I'm going to take everything and move it on the quadratic side, the x squared side. So I'm going to subtract the x from one side, subtract it from the other. Subtract the 12, subtract the 12. So when I subtract the x and the 12 over here, I'm going to get 0 equals x squared minus x minus 12. Again, many methods of solving this quadratic, which we've reviewed earlier in the semester. I'm going to do this by graphing. So I'm looking for two numbers that multiply to negative 12, but add to be negative 1. Multiply to negative 12, add to be negative 1. So those numbers are negative 4, so I'm going to have x minus 4, and positive 3, so x plus 3 is my two factors. Anytime you're solving by factoring, first step is you factor, then take each of your factors and set them equal to 0 and solve. So I'm going to have x minus 4 is equal to 0, and x plus 3 is equal to 0. I'm going to solve each of those. I solve this left one, I get x is equal to 4. Solve the right one, I get x is equal to negative 3. But again, before I box these and move on, what I'm going to do is I'm going to take those answers and I need to plug them back in to make sure it works into my original problem. So I have to kind of ignore those squares there. I have to plug these back into the original, make sure they work. So as I'm checking here, if I plug in 4, I'm going to have 4 plus 12 to the 1/2 power equals 4. 4 plus 12 is 16. So 1/2 is equal to 4. Remember, if you have anything to the 1/2 power, you can switch that over to radical form. That's just like taking the square root of 16. Well, the square root of 16 is 4, so we get 4 equals 4. Another way you can do that You can just type in your calculator, take 16 and then do the exponent and 1/2 power and you'll get 4 as well. 4 equals 4, so that works. So what I know is x equals 4 is a solution. Now I want to check and see maybe x equals -3 is a solution. So plugging it in, I have -3 plus 12 to the 1/2 power equals -3. -3 plus 12 is 9, so I have 9 to the 1/2 power equals -3. And again, you could use your calculator here, or you can convert from 9 to the 1/2 power to the square root of 9. But 9 to the 1/2 power, you're going to end up with 3. So we get 3 equals -3. Those are not equal. One's positive and one's negative. So what that tells you is our math was correct up here. And we got x equals -3. The only thing is, this is an extraneous solution, which means you think it's a solution, but it's not. It is not one of our solution sets to this problem. So only x equals 4 is a solution. And that was solving equations with rational exponents.